Hi, so I'm Andrew. I'm an undergraduate at Cornell, majoring in biology, and today I'm going to focus on talking about avoidance behavior in smallmouth bass and how we can apply this to invasive species removal. So first off, I want to thank the Forney family for helping to fund my research, and I want to thank everyone who was instrumental in the data collection process. And I also want to thank my advisors, Dr. Zoe Almeida and Dr. Tommy Detmer, for their advice and guidance throughout this process. Oh. There we go. So first, I'm just going to introduce invasive species. Like we've already mentioned throughout the previous talks, invasive species are species that are introduced into a new ecosystem that they're not already native to. And this can pose a lot of economic and ecological impacts. For instance, a lot of invasive species tend to disrupt biodiversity levels, and they also impact food webs. On the right there, we have two examples of prominent invasive species. The top right is zebra mussels, which tend to filter water, which uptake nutrients from their environment, which prevents a lot of native species from getting the nutrients they need to survive. And then on the bottom right-hand corner, we have the round goby, which tend to have a lot of offspring, and they also like to feed on the eggs of a lot of large predatory fish like lake trout and smallmouth bass. So because of the problems associated with invasive species, a lot of ecologists like to look at how we can better manage and control their populations. So first they try to better understand how we can prevent their growth and try to slow down their control. On the right there is an infographic from the New York State DEC discussing how to properly clean your boat to prevent a lot of aquatic species from infiltrating different water bodies. And then when these prevention and control methods don't work, we tend to look at removal methods as a better way to try to stop their population growth. And a lot of common removal methods include harvesting and trapping, and the biggest removal method that we'll discuss in the rest of this presentation is electrofishing. Okay.
Yeah, that's good.
Right there?
Yep. Thank you. So now this leads us into how does the removal of invasive species affect their behavior. So a lot of literature that's already published poses that removal will cause the removal of more aggressive fish from the system, and this will leave behind more fearful fish. And a lot of this literature focuses on marine systems, particularly marine protected areas versus non-marine protected areas. So in marine protected areas, we tend to see more aggressive fish, whereas in non-marine protected areas, we tend to see more fearful behavior due to the removal and angling pressure. And this leads us down the line into implications for invasive species removal, which we'll discuss later in the presentation. So now this leads us into how does this relate to smallmouth bass. So smallmouth bass were introduced into the Adirondacks through intentional stocking programs. And although they're really cool species to go after in terms of fishing, they tend to pose a lot of detrimental impacts for other predatory fish species like lake trout and brook trout. They commonly tend to outcompete them for prey. And because of this, in 2000, the Adirondack Fishery Program began the removal of smallmouth bass from Little Moose Lake through electrofishing. Thank you. So then this leads us into our main question for the study. How does electrofish removal impact smallmouth bass risk aversion behavior? And to look at this, we mainly focused on flood initiation distance, and we also took into account a few other covariants like depth of fish, fish length, and we also looked at flood initiation distance for pumpkin-seed sunfish to account for any differences across non-target and target species. So for our hypothesis, we predict that electrofishing removal will cause an increase in smallmouth bass risk aversion behavior, which would be associated with higher flood initiation distances. Whereas for our non-target species, the pumpkin-seed sunfish, we predict that there will be little differences across our different treatment groups. And we also predict a relationship between depth and flood initiation distance, and also length and flood initiation distance. So now we'll go into our treatment groups. So, like I touched on before, our removal group is the electrofishing group at Little Moose Lake. Our two control groups are sand and woodhole lakes. So these lakes see little to no human exposure. The fish are not really used to any sort of human presence. There's little to no boat activity at all, and there's little to no fishing activity as well. And also we had an angling group where we tried to look at the impact of catch and release fishing pressure on smallmouth bass behavior, although we didn't get much data, which we'll touch on further in the presentation. So for our methods, as you can see, I'm very creative. Like I touched on, flood initiation distance is the main measurement that we focus on in this study. And it's essentially the distance between my position and the point at which the fish flees due to my presence. And we're essentially using this as a measurement for how fearful or aggressive the fish is. So I swim up to the fish swims away, and then I drop my anchor, marking my location, and then another anchor marking the fish's location, and then measure the distance across for that flood initiation distance. So for the data collected during our snorkeling surveys, we looked at FID, and then we also touched on covariance like length and fish depth. We also looked at transect info like cloud coverage, location and time of day. And we also touched on fish habitat to see whether there was an effect due to substrate type, whether the fish was around structure, what type of structure the fish was on, and whether the fish was in a group or alone. So overall, we encountered 225 fish. We got a good stretch of data throughout all of our treatment groups, except for Oneida Lake. We really struggled to find any smallmouth bass in Oneida Lake. We predicted that they'd probably be a little too deep to be able to see with snorkeling gear. So yeah, that was a little disappointing. For size ranges, we got a good size range, 1 to 18 inches for smallmouth bass, 2 to 6 inches for pumpkin seed. And then for our depth, it was 1 to 14 feet. We really struggled to get any deeper depth ranges just because we were using snorkeling gear, and obviously with the anchors, it was really hard to re-obtain our weights after dropping them. So now we'll go into our results. So PS on the right side stands for pumpkin seed sunfish, and then SMB stands for smallmouth bass. On the x-axis, we have our 3 treatment groups. LML is Little Moose Lake, SDL is Sand Lake, and then WLL is Woodhole Lake. So as you can see for pumpkin seed sunfish, there's little to no difference across all 3 treatment groups. There tends to be an overlap actually between flood initiation distance for all those treatment groups. So from this we can kind of attribute that the smallmouth bass the pumpkin seed sunfish exhibit similar behavior across all of our treatment groups. And then for smallmouth bass, our 2 control groups, which are Sand Lake and Woodhole Lake, exhibit very similar behavior. Although Little Moose Lake exhibits much larger flood initiation distances, therefore we can say that the smallmouth bass in Little Moose Lake are more fearful, and we think that this is because of the electrofishing removal that we're conducting. So now we're analyzing the covariate of length. So on the x-axis we have fish length in inches, and then we still have flood initiation distance. on the y-axis. So for all of our groups here, we have a positive slope, indicating that when we have a larger fish of longer lengths, we'll also tend to have a higher flood initiation distance. Therefore, we can attribute some sort of relationship between length and flood initiation distance. So for our main insights, we saw that smallmouth bass tend to have larger flood initiation distance in removal areas, which we can attribute to more fearful behavior. And also, fish of longer lengths have higher flood initiation distance. We didn't focus on depth just because we didn't find any other relationship between flood initiation distance and our other covariants. And then also, so how does this come back to invasive species removal?